Welcome to Custodial Crypto. Today I'm going to talk to you about the BIP-119 upgrade, also known as CVT, and just generally how the network is going to upgrade and develop in the future. So if you're a trader or a long-term investor, this may give you insight to certain catalysts or events that could change the price. Because I think fundamentals are overlooked by most crypto investors. How the tech works and what it can do definitely has an impact on the price. So for example, if you traded around the last two Ethereum upgrades, you can see that they're both pretty good long-term entries. So you have the Petra upgrade, you have the merge of 2022 when ETH went from proof of work to proof of stake, and it ran up all the way to 4K. And we just had the Petra upgrade in May, which had some really big fundamental changes to the network. It's made it a bit more centralized, but I think it's made it more interesting to institutions. And as you can see, since then, it's been running up quite aggressively. On the other hand, however, the last Bitcoin upgrade, the Taproot upgrade of 2021, marked almost exactly the top of that cycle. I couldn't really find any examples or any reasons why, because the upgrade seemed to be quite bullish for the price in fundamentally. So not to say that this new upgrade would mark the top of this cycle, but as we know, past performance doesn't guarantee future performance, but history can rhyme or repeat itself in the crypto market. So why does the network need to evolve? Well, first of all, network transactions have reduced. With ETFs and derivatives like perpetual futures and CME, there's not really a need to buy Bitcoin on-chain anymore. You just buy an ETF that invests in Bitcoin, or you buy a futures contract that mimics the price of Bitcoin. So wallet creations have fallen to their lowest since 2018, and miners' revenue has decreased. Post-halving, this is normal because the halving means that mining new blocks in the network has half the price they used to earn. So post-halving, it's normal for miners to struggle, but with all this paper Bitcoin going around, this cycle, the price has been easier to control, a lot less explosive, and we've set all-time highs multiple times, but we kind of just has popped our head out the top, and it's kind of gone sideways after that. So this is a reason why the network needs to have new use cases. Other than being digital gold and having a great store of value with its fixed supply, Bitcoin doesn't really have any other use case other than just price go up at the moment. So Bitcoin has always had smart contracts. So they're programmable contracts that automatically execute on-chain when certain conditions are met and require no middlemen. But these contracts have been very limited in their use. So two examples are multi-sig contracts. Two parties need to sign off to authorize a transaction, and time lock contracts. Transactions are only valid after a certain amount of time has passed or blocks have been mined. This is because the Bitcoin script is very simple and it's non-Turing complete, unlike Ethereum, which is the first Turing complete blockchain. So what is Turing completeness? Without complicating things too much, it means that a blockchain would be able to perform any computation given enough time and resources. So it can create more complicated branches that are executed within certain conditions. So if, and, or, not. And it can repeat operations running endless loops on itself until it figures it out. These obviously can use a lot more energy because depending on how complicated the computation is, it could technically use an infinite amount of energy. When you compare to the Bitcoin script, every block is guaranteed to finish and no external logic is allowed on the layer 1. So this ties to the Bitcoin trilemma. Every blockchain has this issue. If you boost one of these, you have to do it at the cost of another one of these. So with Bitcoin, it's incredibly secure. It has simple logic, so you won't be able to exploit the network unless if you had a quantum computer, for example. They've been talking about quantum computing risk, but that would require like a stupid amount of energy. It's also secure because to pass new upgrades like this one, I think up to 90% of the miners need to be in agreement for it to pass, which is why it's quite hard for these things to go through. It's very decentralized because the hash rate that secures the network, number one, is it's a very high amount of energy that is needed, and the hash rate is distributed all over the world, although we know that certain parties want to try and control a majority of the network. But what it isn't is very scalable. So the network is quite slow and it has limited uses at the moment. So this leads us to the Taproot upgrade of 2021 and the introduction of Schnorr signatures. So what they did is that they aggregated multi-sig transactions into one. Previously, it was publicly broadcasted if anyone was using any type of smart contract capabilities. So say if there were any bad actors that wanted to interfere with smart contracts, it would have been a lot easier because they were all visible on the blockchain. After this upgrade, all transactions became uniform, so they all look the same on chain, regardless of whatever logic you've been using. So this improved privacy, this reduced data requirements, and in turn, it increased the speed of the network. So the Taproot upgrade did have some controversy. Sometimes changes to code have undesired effects. In this case, asset minting became possible through a loophole, bringing NFTs or Bitcoin ordinals to the network. How this works is that data could be added to transactions such as images or text, and they'd be inscribed on Satoshis, which are the smallest unit of BTC. So now they live forever on the blockchain, they're immutable. Certain Satoshis have messages added to them or cyberpunk images or whatever degen stuff people have been doing. So I'm hoping you like the content so far. Please like and subscribe to the channel to help grow the channel, and check out my YouTube shorts. They're explaining videos that break down complex fundamental topics and keep up with the news, so you can be informed of what's going on in about 30 seconds. There's no excuses to not be informed anymore. So yeah, you can watch these on YouTube shorts or on TikTok as well. And so this brings us back to the main topic, the BIP-119 upgrade or the CVT upgrade. What are they planning to introduce? So covenants and smart vaults. Smart vaults can allow a user to determine who they can send their Bitcoin to and block all the other addresses. And it can put limits on how much can be sent at a time as well. So this can be executed automatically and on a recurring basis. Personally, I'm not necessarily the biggest fan of some of this because this is done using cold wallets, which is offline wallets. If I'm keeping crypto offline, I don't really want any type of programmability that's able to change that fact. I'd rather just do it manually. But there are definitely some benefits. For example, succession. If something ever happened to you and you pass away, how do you transfer your Bitcoin to your children? Well, it could be done in a programmable way on the blockchain and be pre-programmed. So if something was not to go to plan, the money would just be sent back to the cold wallet originally. So this part of the upgrade is mainly targeted at institutions because they hold very high amounts of Bitcoin and they don't want to give access to employees. They don't want to give the private keys to the employees because they could technically send the money to themselves and disappear and live a great life. So an example here is an institution with money stored offline or Bitcoin stored offline. They send it to a lukewarm wallet, which also has a covenant in place, meaning it can only send it to specific places like a hot wallet. It could be an exchange where the Bitcoin can be sold. And after a certain amount of time, if the money is unspent, it will just be sent right back to the cold wallet. So this would greatly increase the trust in the network. This could bring new use cases like Bitcoin bonds. Institutions can lend each other Bitcoin, and they can ensure that interest will be paid in a programmable way on the blockchain, and that the final or the initial loan gets reimbursed as well automatically. And another improvement of the upgrade is batch transactioning. This is the same as ETH. So essentially, Ethereum, the base chain, sends off transactions to side chains that process transactions for a fraction of the fee, and at a lot of a faster speed. And you can now batch and bundle hundreds of transactions together in one transaction on the main chain. So this could potentially increase the speed of the Bitcoin network from about 5 to 10x, taking it from about 7 transactions per second up to as much as 50 transactions per second. So what exactly is a Bitcoin layer 2? Well, it's any system that runs on top of Bitcoin and relies on Bitcoin for settlement and security, and processes transactions off-chain. So there are technically risks with this because you're sending Bitcoin off the main chain where the logic is fixed and very secure into a different execution layer where the rules are potentially different. And if a certain party had too much control over a layer 2, then they could potentially censor transactions. It could be way too centralized, so they can have too much power over what happens, and it could be opaque as well, so we don't know exactly what's happening on these side chains. But there are ways to make sure that layer 2s continue in the same ethos as Bitcoin, because the reason we left the TradFi system, a system that we can't necessarily trust, is because Bitcoin's meant to be permissionless. You trust in the code. You don't look for any individual or institution to give you authorization. And this kind of ties into the trilemma once again. You need it to be secure and you need it to be decentralized. So a well-designed layer 2 should always allow users to exit back to the L1 trustlessly. Essentially, the L2 should be able to punish bad actors that are acting on the L2 and allow anyone to go back onto the Bitcoin main chain whenever they want. So there does need to be enforcement against any potential bad actors on the layer 2, such as penalty transactions. Trust needs to be minimal in operators, as I said, so that it can't be too centralized, where a company, for example, does all the transactions on the L2. Otherwise, it doesn't really make much of a difference to the TradFi system. So it needs to be user run. Any individual should be able to run computers on the L2, audit the L2, so see all the transactions happening and detect censorship or fraud. And this is where the upgrade comes in, because if the Bitcoin layer 1 now has more smart contract like logic, instead of having the L2 punish bad actors, the L1 can punish them themselves and solve any disputes and essentially act as a referee. So there wouldn't need to be any trust in layer 2s because the layer 1 is completely compatible. So we're going to go into how the Lightning Network works. I'm sure you've heard of the Lightning Network. It's a layer 2 protocol that allows fast, cheap and private transactions of Bitcoin off-chain. The speed is basically instantaneous, but it has had problems gaining traction because it requires specific type of software. Okay, so we're going to give an example of how the Lightning Network works. 2 people create a multi-sig address. So let's say they both put 0.5 BTC in it. This creates one BTC UTXO all these layer 2s, everything built on Bitcoin works on UTXO, which is unspent transaction. It freezes the Bitcoin on the main chain, and then on the side chain, more complex transactions happen, and it can be updated on the main chain later. So off chain now, you have one BTC has been frozen, and you can choose how to split it, and you can send these transactions instantaneously. The channel can stay open for as long as you want, so you can keep back and forth sending transactions, and a receipt is just updated, not the actual blockchain. Whenever any party wants to close the chain, they just broadcast the transaction to the main chain, and the new balances update on the main chain. And so this is useful because it's instant, it's cheaper as well than a Bitcoin transaction, and you can essentially make 20, 30 transactions and it will only be settled by one transaction on the main chain. But that's the Lightning Network in its most basic use. In reality, the Lightning Network is a network of payment channels, multiple payment channels that can send all sorts of transactions to people that don't even know each other, which is why we were talking about batch transactioning earlier. Lightning would have the same capability. So the Lightning Network can be seen as a network of friends who have a joint bank account with each other. You don't need to open a channel with somebody on the main chain to send them money on the Lightning Network. The way it works is that the transaction is forwarded to someone that does have a channel open with them. So you want to send money to Carol, but you don't have a channel open with Carol, but you have a channel open with Alice, and Alice has a channel open with Bob, and Bob has a channel open with Carol. So each channel updates its local balances, forwards it until the person receives it. The Lightning nodes, or the people running the Lightning Network, are the ones that ensure that no fraud is done, using something called hashed time clock contracts. So the payment is hashed with a secret, and the person can only claim the funds if they provide that secret. If the transfer is instantaneous anyway, it would be very hard for somebody to claim the funds before it's even received, or not forward the funds. And all the computers are checking that this works correctly. So if anyone does try to cheat or the transaction doesn't work, the payment will just expire and return funds to the sender. And so Lightning wallets are different to regular on-chain Bitcoin wallets. The channel balances are kept off-chain. You can't see how much somebody has on-chain. They use a different logic, and they use obviously a different channel, meaning that they are a separate type of software. So you would need a wallet that is compatible with the Lightning Network. And here's a list of them. So Phoenix, Breeze, Zeus, Wallet of Satoshi. Some of them use both on-chain and Lightning support, and some of them are a bit more centralized as well. So you need to have a look at that, because you really need to be able to trust whoever's operating it. And this has limited the scalability of Lightning because it's not one of these big apps that you can use like Coinbase, either you wouldn't want to use a centralized exchange, but it has just meant that it's slower to gain traction, and the user experience might not be as good as a centralized app. Also, you have to understand how it works, and yes, many Bitcoiners do not understand how the Lightning Network works and don't fully trust it. On top of that, you have to run Lightning nodes, which are different to Bitcoin ones, liquidity in them to be able to forward funds. But these nodes do earn, I think, a small fee through facilitating these transactions like Bitcoin miners do, but obviously it's going to be a lot smaller as the transactions are cheaper. And this takes us to the next layer 2 network. So this is the RGB protocol, and in the future they plan to bring tokenized assets and especially USDT to Bitcoin. Obviously stablecoins have a lot of hype at the moment. They're used by a lot of people for remittances and other things. So that being put on the Bitcoin network will bring a lot of new use cases to Bitcoin and more adoption. And just like the Lightning Network, RGB uses client-side validation, so anyone can run a node and validate transactions and check what's going on the network. They plan to introduce Lightning-based atomic swaps, which means that you can switch Tether for Bitcoin on this layer 2 instantaneously, and this protocol is going to be compatible with Lightning. So this is basically where the possibilities become endless for Bitcoin, because it allows you to build any DeFi logic on top. So Ethereum, think Ethereum virtual machine compatibility, staking, lending, borrowing, what else? Stable coins, all of that on the Bitcoin network without actually having to go to any other sort of layer 1 chain. So now my Bitcoin can be used to transfer stable coins, my Bitcoin can be used to borrow money on the protocol, all of this on the protocol level without actually having to go through any centralized authority. And what's super cool about this is the privacy, because Tether have been known to freeze transactions on Ethereum, for example, if the government have told them to. But with the RGB protocol, it would be different. So since the tokens are managed on client side, peer-to-peer, no centralized issuer controls the tokens. So once they've minted the USDT, it'd be impossible for them to freeze the tokens unless if RGB allowed it at the protocol level. So they might not make it like a legal form of exchange through certain TradFi institutions, or they might try and pressure wallet developers or ban it from the App Store. But the most important thing is that if enough individuals accept it as legal tender, which after this Genius Stablecoin Act, it means they're a lot closer to being fully legit. You wouldn't really care. Your USDT can exist on the Bitcoin base layer, and either way it's switchable for Bitcoin at any time you want. Moving on now to Arc, another Bitcoin layer 2. What makes it different from Lightning is that users can receive Bitcoin on Arc instantly without having to open channels. And it's trustless as well, so it has unilateral exits. Anyone can reclaim their Bitcoin from Arc at any time without needing to trust the protocol. So Arc doesn't need any type of pre-funded wallets to validate, to transfer funds. So transaction fees are lower. However, and it's has higher privacy. However, it is more centralized, so it does have central coordinators. So you do need to have a degree of trust in these coordinators. But yeah, with its compatibility with the main chain can step in and validate transactions if there's any issues. And here we go again. So Bitcoin DeFi, NFTs, tokenization will all be available on the network, but it's still in development and experimental phases. What we've seen with a lot of Ethereum layer 2s is that they all make their own token. I hope that most of these Bitcoin layer 2s don't make their own token, because I feel like a lot of these coders, etc., they can't help it but make themselves rich. At the same time, they do a lot of hard work, so it makes sense that they want to get paid for it. And here's another Bitcoin layer 2. So we have build on Bitcoin, which is a hybrid layer 2. And they aim to roll out the first Bitcoin layer 2 that is compatible with the Ethereum virtual machine, so an Ethereum bridge. But the concept remains the same, so it has off-chain logic, but then is verified on-chain. And they are in partnership with the Bitcoin virtual machine, or BitVM. So the BitVM protocol, Bitcoin is locked into the BitVM in smart contracts, and again uses UTXO. So it creates a token called YBTC which is pegged 1-to-1 with Bitcoin, and that Bitcoin is frozen on the main chain. So yeah, it's backed 1-to-1, and with this token, DeFi activities like lending, borrowing, yada yada, become available. So YBTC is already available on Sui, and the Bitcoin virtual machine just launched their mainnet, meaning users can mint bridged assets and perform smart contract operations backed by real BTC. Miners are validating what's called non-standard transactions. So not all type of miners are compatible with certain layer 2s. About maybe a third of the miners are. But now that this is the case, it means that they have true security of the Bitcoin network, with a third of the miners checking for them. So it is still early on, liquidity is limited, and people are still waiting for stable coins to come onto these networks. But they already have integration with Sui, Base, so the Coinbase layer 2, on Ethereum, Arbitrum, Starknet, Sonic, which I think is also connected to Solana, and Cardano with the Cardano protocol. And so that's it for the video today. So yeah, Bitcoin will have DeFi and all sorts of other new use cases in the future. Please like and subscribe for more content like this. I've definitely learned a lot making this kind of video. The layer 2s are extremely complicated and they're very early on in their progress. But yeah, make sure you like and subscribe for more content like this, and peace out.